Assalamualaikum, good morning. Our group will present the problem of question 3, which contains 3.1 and 3.2. And 3.1 is the concentration in a chemical reaction, and 3.2 is the Fehrenheit speed for mass flow. So here we need to find the rate of change with the given time and explain whether the rate of change is increasing or decreasing, and what are the implications for industry. Therefore, in question 3.2, we need to find the blade speed that maximize airflow. To solve the problem and what method need to use, I leave it to Anif Aika.
I will explain the mathematical method. The concentration in a chemical reaction problem. Our point is to find rate of change of concentration over time. Method we use is quotient rule, which is function we apply into the rule. First step, we should find the numerator and denominator. After that, we will find their individual derivative. After find their numerator, derivative and denominator, we apply into the formula and solve the equation. After that, we just insert the value of t and to find the speed at exact time. Meanwhile, in Fehrenheit speed problem, our goal is to find the specific input to produce the maximum output. The method we use is product rule and chain rule. First step, we need to apply this equation in product rule to find the first derivative from QW to Q prime W. For the chain rule, we use to find the difference in par e the power of negative 0.5 W. Last, we just solve the equation to find if the point is higher or not to put on the graph. For the graph, we will use the digital tools, which is Desmos.
So here I will explain how to solve the 3.1 question, which is concentration in chemical reaction. So in this question, we're going to use quotient rule method. So here, the question, we're going to take the 50T to be an U. So U equal to 50T. So then we take T power of 2 plus 2, going to be V. So V equal to T power of 2 plus 2. Then U, we're going to depreciate 50T, depreciate to U prime. So U prime equal to 50. So V, depreciate to V prime, we're going to get it to UT. And then after we depreciate all, so we're going to insert it to formula. What is the formula? Formula is so U prime times V minus V prime times U divided by V power of 2. So we insert it, all the answer here. We settle down it. Then the answer for the last one is 100 minus 50T power of 2 divided by open bracket T power of 2 plus 2 close bracket power of 2. And then we evaluate when T equal to 3. T equal to 3 is already given by question, so we insert it into the formula here. Then we solve it, we're going to get minus negative 2.893. That's the answer for question 3.1. Alright, so we go to question 3.2. Okay, so we're going on to 3.2, which is fan blade speed for maximum airflow. In this question, we're going to use product rule and chain rule. So, product rule, here is question 40WE power of minus 0.5 W. So here, we're gonna take the 40W, gonna be U, so U equal to 40W, and then we take E power of negative 0.5 W as a V. So V equal to E power of negative 0.5 W. So here for U we depreciate it. U prime equal to 40. Then V depreciate it, we're gonna have it V prime equal to negative 0.5 e power of negative 0.5 w. So we insert it into formula product rule, which is u prime times v minus v prime times u. So we insert it, then we're gonna get it for dq and dw. Divide by dw, 40 e power of negative 0.5 w minus 20 w e power of negative 0.5 w. So when dq divided by dw equal to 0, so 20 w e power of negative 0.5 w open bracket 2 minus w close bracket equal to 0. So negative w equal to negative 2. So the final answer for w equal to 2. Okay, so that's all for question solving.
I'll be explaining about the digital graph we've been done using the Desmos graph. For the first graph, it was done using the question 3.1, which is the concentration in a chemical reaction. In the first column, we can see I've write the question given, and next I add the rate of change based on the equation we've been solved. And for the last one, the point 3 equals to 3 are based on the equation 2. Let's move on to the second graph. For this, I use the second question, which is the 3.2, the fan blade speed for maximum airflow. Like before, the first column are filled with the question given. Next, the two you see right now are because it is the maximum point of the graph.